Thank you, Emily. I don't think it looks crazy. I think it's the future. Well, thanks to everyone. Do we have 5-10 minutes for a short, 5 minutes, or we may go to 10 with a margin. So I would like to take questions from the audience. I mean, if you have a couple of questions to address to the speakers, please do so. I guess a microphone will be circulated.
Thank you.
One
for the speaker.
Yes, of course. Thank you. So please ask your questions.
Thank you. So my question is probably more for Teddy, but I don't know if he's still online. Anyone can answer though. It's about Mars. Since Martian helicopters are working so well, could it be that Perseverance is the last ever NASA rover on Mars?
Jim, well, I have some difficulties hearing, so I'm not sure I could repeat your question. So Maria Antonetta, you want to answer the question?
No, I don't think so. To explore, helicopters can be very effective, but then to carry on payloads and to do operations with what there is on Mars, you need rovers. And for sure we have ExoMars rover, but I don't want to be partisan. There are rovers from many different countries.
I wonder if I can chime in. Can you hear me?
No, I don't believe so, because landers are, they land in a specific zone, but then you need mobility to extend your exploration range. Sorry.
Okay, thank you for answering. I see that Ralph Lawrence is online. Ralph, you're online?
Yeah, can you hear me?
Great, yeah, sure. Thanks for staying with us.
Yeah, I'd maybe answer the question a little bit too, because we confront this question with Dragonfly. So if your scientific goals pertain to interacting with the surface, and in particular sampling surface materials and analyzing them, there are some interesting challenges when you try to do that with an aerial vehicle. We have a team at Honeybee Robotics that build our sampling drill. And the first parameter that people designing drills worry about is what they call, the weight on bit, right? The downforce that holds the bit in place against the reaction as you drill. And that is something that aircraft designers aren't used to thinking about, right? You want your aerial vehicle to depart the ground as easily as possible and weigh as little as possible. And so I think as was just said, for reconnaissance, aerial vehicles are great, but for certain kinds of persistent science, seismology that Dragonfly does, that's best done from a fixed platform, and there are definitely compromises that have to be made in the quality of those measurements associated with flying. And interaction with the ground sampling really is best done from a lander or a rover. And you can see even the sample return helicopters that Teddy showed, right? There's sort of been an evolution from the pure helicopter ingenuity to having wheels for that last 2 or 3 meters of close interaction with the sample tubes. So I think rovers are not gone. They're going to stay with us.
Okay, thank you very much, Juan. Another question? Yeah.
From Jean-Jacques de Chézelle. So I'm supporting the Dragonfly, as well as Jean-Pierre Le Breton, Roger Maurice Bonnet, and some others who participated in the Cassidy-Huygens mission. And since about 20 years, we are dreaming to return on Titan. My question is an engineering questions. How difficult is the mass budget?
That's a question for you, right?
Yeah, I mean, every aerospace project encounters mass growth challenges, not just spacecraft. As you get into ever finer levels of analysis, you realize that you need to bookkeep the wiring harness and the little loops that hold the wiring harness in place. To answer a slightly different question, I often get asked, what is the most challenging aspect of Dragonfly? And really the genius of it, I suppose, was recognizing that all the challenges are solvable, right? The overall concept is crazy, right? But then when you start to think about it, all the crazy challenges, how do you work on a body that's 72 light minutes from Earth? How do you operate in a cryogenic environment? You realize that all those challenges are individually solvable, right? You get some smart engineers, there are solutions that exist for all these things. In terms of what challenge is maybe harder than it might look, probably the thermal one. We're working hard to balance the demands of staying warm on Titan if it's windy and the convective cooling is strong, versus managing the heat that is dissipated in the vehicle when we dissipate 10 kilowatts to fly, and just the attaching foam to a structure. Those are a lot harder than you might think, but we'll get there. The real difficulty is that a vehicle like Dragonfly, because it's so tightly integrated, and this applies to Ingenuity and the SRH as well, you cannot touch anything without touching everything, right? You want a little bit more power from the rotors to fly faster, say. Then you need to put more current into the motor windings. So you need, thicker copper wires to the motors. Those thicker copper wires are a more conductive heat leak from the interior. So now you need more insulation. So now the insulation is bigger and there's drag. So now you have an aerodynamic penalty associated with trying to get more flight power. So everything is connected. And as we go through that design loop, there has been mass growth on Dragonfly, but we're well within the maximum permitted values. We had the preliminary design review, with the standing review board earlier this year, and the technical baseline is ready to go.
Well, thank you, Ron. Another question.
Hello, hi. I have a question for Dr. James. According to your slide, the Venus rover will land on the Venus before a curse with a balloon, right? With a balloon, right? And we know there is a very huge storm in the Venus atmosphere. Will that make the cruise of the balloon kind of uncontrollable? How much it will affect this process? And is there anything to reduce this problem?
Maybe can you repeat?
Sorry.
Sorry.
I mean, according to your slide about the balloon in Venus, will the storm in Venus affect the wind, the high-speed wind, affect the move of the balloon?
Will a storm affect?
Yeah.
Okay.
Okay.
So the answer is yes, a storm would affect the motion. Just to give you a sense of the circulation, there's a super rotating nature to the Venus atmosphere. The balloon will travel around the planet in 6 hours, in six Earth days. There are various kinds of storms that have been identified, but they're not fully understood what they actually would mean for a vehicle in situ. We are prepared for tolerating wind changes, and particularly updrafts and downdrafts, up to about 3 meters per second, and still maintain our flight path. We can probably tolerate updrafts and downdrafts 5 meters per second without damage to the vehicle. Does that answer your question?
Yes, most part. So can we make a prediction or make a control to the final destination of this balloon? Sorry, I mean, can we control or can we predict the final destination of this balloon? Where will it go at the end?
So can we control the vehicle against these disturbances?
No. Can we control or predict the final destination of this balloon? Where will it end the travel?
Well, there's a level of control we can achieve with just vertical control of the vehicle. And that works in much the same way as it does on the Earth with hot air balloon flights, or some companies like Google company were using altitude control to change the trajectory. On Venus, we believe we're going to be able to do that, but at this point, we don't have enough knowledge of the difference in the motion as a function of altitude. The kind of measurements that exist are based on cloud motions, but the resolution in velocity is quite poor. But we suspect that once we get into the atmosphere and begin to experience what the motions are really like, that we are going to be able to control our trajectory. And in particular, since we're sweeping around the planet at around 80 meters per second, we believe that we're going to be able to change the north-south position of the vehicle, so we're going to be able to cross different features. So for example, if we learned from one of the orbital flights, like in Veritas or Envision, that there was an active volcano, and we'd like to pass over that volcano, we'd be able to migrate the balloon as it traveled around in a 100-day mission. It'll circumnavigate the planet 20 times. We'll be able to control the latitude so it passes over that flight.
Okay, thank you very much.
Okay, so, okay, one last quick question, and we'll try to give a quick answer. That would be the very last one.
Okay, I'll be very quick. The question is related to the previous one, so the balloons. And my question concerns the aspect of the deployment in the atmosphere. So how do you intend to tackle the difficult possibilities that the atmosphere could bring? Maybe you said that you are not so sure about the entities of the phenomenon, the storms, the wind, and so what are the different solutions, the deployment solutions that you think, that you thought in those years?
Okay.
Well, the short answer is caution. What we will do is, when the vehicle is first deployed, it'll fly at what we believe to be a safe altitude, which will be in the region of 55 kilometers. And for the first 2 or 3 or 4 traverses of the planet, it will fly at that altitude. Now, as we gain experience, and you know, the Venus atmosphere is very complicated. There are clouds at different levels, and the solar input will undoubtedly vary quite a bit. As we gain experience, then we'll be able to venture further and further away from this nominal altitude. There are, of course, there's always the unexpected, and you know, I think we'll be prepared to deal with this. The nature of this vehicle is such that there are natural restoring forces. So if there are perturbations that push it away from its nominal altitude, there's a restoring force in the form of this superpressure balloon that will bring it back to that altitude.
Okay, thank you very much.
Okay, so thanks. So we are going to close the session. So first of all, I would really like to thank the speakers for their excellent talks, excellent preparation, and to Ralph for staying online. So I think for me this was an excellent, lots of ideas. In the present helicopters, the Dragonfly or the Titans, that's really exciting. But I think there are really, for me, a bright future for flying machines from Venus to Uranus and why not Neptune. So balloons and flying machines have a potential for really increasing the science capability of the mission in the next decades, before the end of the century, probably. Okay, that's my conclusion. So before we have the next keynote, let me make sure I have it. Yes, the keynote is at 14:15. So please, this is a keynote by the astronauts, Samantha Cristoforetti, and astronauts are on time, so be on time a few minutes before 14:15 if you don't want to miss the beginning of our talk. Bon appétit.